Good morning and welcome to the fourth webinar in the Towards a Low Emissions Future series run by the New Zealand Agricultural Greenhouse Gas Research Centre and the Ministry for Primary Industries. I'm the chair for today's session, Harry Clark, and I'm the director of the New Zealand Agricultural Greenhouse Gas Research Centre. This session is titled Knowing the Numbers, and it will provide up-to-date information on the tools currently available and under development to enable New Zealand farmers and growers to estimate their on-farm greenhouse gas emissions. For those of you who have attended the previous ones, this will be familiar, but for any new people, the format of this is that we have recorded the talks and they will be available after the session has finished on our website. Each talk will be followed by questions, and today we have 5 talks. So to try and minimize some disruption, we will have a 15-minute talk followed by 5-minute questions. We then have 3 short presentations, which we will follow by a question and answer session, and then followed by a 15-minute talk, followed by a question and answer session. We will be able to answer some questions coming from the audience, and can you please submit your questions as we go along, and we'll get through as many of those questions as we can. If you see a question you like or agree with, can you please use the upvote button, the thumbs up button, so we know that that's a popular one and we can direct the most popular questions to the presenters. If your question isn't answered or it's been dismissed, it doesn't mean that it won't be answered. We will be looking at the questions and providing written answers to as many of those questions as we can. Excuse me. And we will summarize those. So thank you for joining us today. And please remember that we're doing our best to make this as efficient and as successful as possible. And if you have any suggestions for how we can improve, can you please send them through to us? As usual, things don't always go as smoothly as possible. Our first talk was meant to be by Carolyn Reid from Overseer. Unfortunately, Carolyn is unwell, so won't be attending in person, but luckily we do have a video presentation. And in Carolyn's place, we have Alistair Taylor, who will be able to answer questions. So just a little bit about Carolyn. Carolyn has been with Overseer for around about 6 years. She joined in 2014, initially running a very wide-sweeping needs analysis, and since 2016, establishing and running the independent business that is now Overseer. She has a farming background, coming from a Wairarapa sheep and beef farm, but an unusual background in that she studied geology, completing a PhD at Monash University before moving into environmental policy implementation. And she's worked in a number of countries, New Zealand, Australia, and the UK. Carolyn will focus today on an overview of Overseer and the work taking place to help Overseer meet the future needs of farmers with respect to reporting obligations. So thank you. We'll hand over to that first presentation.
Kia ora. My name is Caroline Reid and I'm the Chief Executive of Overseer Limited. I'm going to give a short presentation on OverseerFM, which is one of New Zealand's on-farm tools. OverseerFM was developed by Ag Research and has been set up by Ag Research and the other owners of the tool, the Ministry for Primary Industries and the Fertiliser Association of New Zealand, to be run as an independent industry good organisation, so that New Zealand farmers, and as a consequence New Zealand, can get the most out of Overseer, as it supports farms all across New Zealand to be sustainably run and therefore achieve corresponding environmental outcomes. OverseerFM is designed to support farm planning by allowing farmers to assess different management options on farm and their impact across a range of different environmental losses, including greenhouse gas emissions, as well as looking at carbon sequestration of forested areas in the farm. The system provides enough detail to understand where losses are coming from, and because of its design, enables users to look at the impact of different management approaches and different land uses for the same farm. This means that when decisions are made, they are informed and can avoid pollution swapping. Another key design principle of OverseerFM is that it can be run by entering farm information that the farmer knows or has easy access to. This ensures that its use can be maximised to support as many farmers as possible. We currently have over 11,000 farms set up in OverseerFM, which is equivalent to around half of the country's farms operating in New Zealand. So how does the model work? The way OverseerFM works is to model the nutrients coming into, transferring around, and leaving a farm, as you can see in the diagram. Which is easy to say, but when you think of all the possible variables on a working farm environment, it's quite a challenge. OverseerFM captures the majority of the farm nutrient management practices and enterprise types, and it is designed to enable different farming philosophies, such as organic or regenerative farming approaches, to be described, as well as the more traditional systems. But the more interesting point is that all of those farms set up to generate nutrient budgets for regional councils also have greenhouse gas reports available without having to change a thing. So rather than the 2% of farms knowing their greenhouse gas emissions that we often hear reported, if they opened the OverseerFM account, nearly 50% would. Because the Overseer model is designed to assess the impact of different nutrient management approaches, we have developed a trend analysis report in the OverseerFM tool that shows the nitrogen, phosphorus and greenhouse gas losses as changes on the farm are implemented. Presenting the information like this really supports users to track progress and to avoid pollution swapping. Overseer is sometimes described as being too complex. And as I said before, a working farm environment is complex and every farm is different. So to look in detail at your farm, you need to have some complexity. But the beauty of Overseer is that it is designed to run off farm available data. To help people understand how this data drives the model, we have created an interactive web page that describes the connections between the farm inputs, the model components, and the results. In this screenshot, the inputs and components used to drive the methane emissions are highlighted. When you click on the nitrous oxide, you can see a lot more activity, and this is because of the importance of soil and climate in nitrous oxide emissions. When it comes to the energy use on farm, fuel, fertiliser applications, transportation and electricity can be specified for the farm. Or there are defaults set up in the system for different farm types, because this is not information that has traditionally been collected, but it will be more and more so in the future. So once you have OverseerFM analyses set up, you can view the greenhouse gas profile for that farm, and you can also compare greenhouse gas emissions results in the Compare tool if you are looking at different scenarios. The greenhouse gas report tells farmers where emissions are being generated on farm. In this example, the majority of methane is generated by the animals, and there is a large proportion of CO2 embodied in the supplementary feed being used on the farm. This source information allows farmers to look at where they could make changes to reduce their losses. OverseerFM also provides farm tools for each gas and product footprint reports that provide performance measure information for farm production. In 2019, we introduced a new tool to estimate the carbon sequestration potential of existing or planned tree blocks on farm. This covers native and exotic tree types and comes from the MPI lookup tables. This new tool has been very well received by industry as they take a holistic look at the environmental performance of their farms. Another new feature of OverseerFM that has been very well received is our benchmarking capability. The software now allows farmers to be grouped and show benchmarks for nitrogen, phosphorus and greenhouse gas emissions, in addition to farm management information such as stock RSU. enabling comparisons to be made across the farm groups to support farmers and learn from one another, and also for processors and irrigation schemes to provide wraparound support for farmers. All of these new features in OverseerFM have been developed through engagement with the industry and farmers to ensure that we have a tool that meets their needs to deliver farm sustainability and to support New Zealand to achieve the environmental outcomes sought. According to leading dairy farmer and Dairy New Zealand climate change ambassador George Moss, the new OverseerFM software provides farmers with a way to understand what is happening on farm for both nitrogen and greenhouse gas, providing them with a platform to guide their direction of travel. But to take this one step further and ensure that farmers in New Zealand like George and the country's export potential benefit from increasing the sustainability of production, we are constantly looking for ways Overseer can feed into further value-add opportunities. Overseer recently partnered with Toitu to support the development of their farm certification program. Now farmers using OverseerFM can join up to the Toitu Farm Initiative and use OverseerFM to inform their carbon reduction plans. Initiatives like this will support moving to a low emissions economy through being able to realise value in certified sustainable food production. We probably get the most questions on Overseer about the science model, and so I thought it would be useful to give you a summary of the greenhouse gas modelling. The greenhouse gas modelling aligns with that of the national inventory, with farm-specific modelling added to cater for different farm management options. The modelling has been well reviewed and is published in technical manuals which are available on our website. In terms of recent changes in the modelling, last year we updated some ME factors as a result of one of the reviews. We also included urease inhibitors to ensure farmers using products with inhibitors can see the impact on their greenhouse gas emissions. This year we have updated the emissions factors based on new analysis by Ag Research. We are also, with Ag Research, developing a revised farm-specific nitrous oxide model that addresses some of the problems we have had with the current model on clay soils. For farms wanting to reduce emissions, it's not enough to know how much you are emitting. It's about understanding where the emissions are coming from and what you can do about it within the context of other environmental considerations. OverseerFM provides the ability to do this so that farmers can make informed decisions about their farm businesses. At Overseer, we are focused on providing a tool that enables farmers to look at options to improve their sustainability and to work across industry to increase New Zealand's agricultural product value so that New Zealand can lead the world as a sustainable food producer. Thank you.
Right. Thank you for that talk. As I said, we will have Alistair Taylor here from Overseer to answer questions. One question that's come up is when you present data in Overseer, you're using CO2 equivalents, and CO2 equivalents has been questioned in the literature by some scientists. Will you continue using CO2 equivalents, or do you present data in both the form of the individual gases for comparisons and carbon dioxide equivalents?
Yeah, I mean, I guess that's potentially a question that is better answered by others on the panel, actually, I think. I mean, in terms of why we report in CO2 equivalents, obviously that aligns with the national inventory and what that's outputting, and particularly aligns with what industry are being asked to report at the moment. And so if that changes, if another metric is agreed as being a better or more appropriate measure, we can look at implementing that. But until that stage, you know, we will fit with what our customers are being required to report.
Thank you. Another question that's come up that's quite popular is the one around feed conversion efficiencies and how feed dry matter intake is converted to methane emissions. And if there is a fixed value used for that, how do you account for different diets that can happen on farm?
So, I mean, one of the bit which is quite important for people to understand when it comes to Overseer, and the screenshots from the Our Model page on the Overseer website, which Caroline highlighted during the talk, is hopefully useful for people. Is fundamentally at the heart of Overseer lies an ME model. So we're looking at the energy requirements of the animal, where that energy is coming from, and where it goes to. And so, if you look at what's happened with the shift to version 6.3.3, which took place a week, 10 days ago, the most significant change around that was due to the changes in the national inventory values for a number of feed types. And so if users and farmers who may have seen, there was a small number of farmers who saw a significant change in their greenhouse gas emissions as a result of that. And that was due primarily to the change in the national inventory value for soybean meal. So it's the calculations within the model are taking those values, looking at the ME requirements of the animal, and then converting those through the model to produce those outputs, which we see reported in the greenhouse gas reporting. And that's a really good example of how just by looking at one particular feed type, where those emissions values are changed, then we do see a significant change in what's outputted within the software.
Thank you. Just a final one before we need to move on. It's actually around soil carbon. Does OverseerFM calculate carbon dioxide emissions from organic soils? When the inventory does do that, but is Overseer doing that, or does it plan to do that?
I'm not aware that we do it. I mean, soil carbon is a question that's come up quite often. Obviously, we went around and we were running workshops with farmers and rural professionals last year at the time when the zero carbon discussions were going on. And it was really as a result of questions asked by farmers and rural professionals that the tree sequestration was added last year, because it was seen that, look, we've got this great measure of the bad stuff that's coming off the farm in terms of the greenhouse gas emissions. It'll be really good to be able to understand what the good stuff is that's coming off the farm as well. At the moment, I guess probably defer to Louis regarding soil carbon, but what we did see we were able to do was to include those tree carbon sequestration. And so by linking the software to the MPI lookup tables, we've been able to do that for people. And obviously, with Jeremy on the call, that's a significant advantage for people like the beef and sheep sector, where they've got significant areas of forestry on the farm, and they're now able to understand what the carbon sequestration values of that area is, rather than just having an area which just sits there as being non-effective.
Just a final question about future-proofing Overseer. One of the mitigations that has been studied is low-emitting animals. And in general, how are you looking to incorporate mitigation in Overseer? And is it intended that you could, in future, allow for different breeding values from animals, so that the effect of farmers choosing low-emitting animals can be captured in your software?
Yeah, that's a great question, Harry, and I think it really speaks to why the owners took the decision to invest in moving Overseer from the old legacy software into what we have now with FM, and the software that we have. Really, sort of, we've gone through that sort of 3-year process of getting away from legacy and moving to FM. And that now puts us in a much better position to be able to look at how we incorporate new mitigations, how we encourage new innovations, and how we can work with people who are developing that data. So, Jackie Harper, who came on board for us end of last year as our chief scientist, is looking at a number of mitigations and how we can work with those people who are working on those, including, you know, the methane inhibitor, including the low emitting type animals, which you refer to, and another of other options. So, you know, what we intend to see in the next few years of overseer development is, you know, much more focus on bringing those new mitigations in. You know, and we've started that process 10 days ago with putting the plantain data entry fields finally into the software, and hopefully we'll have the science modelling behind that very shortly. But that's really the direction we go. You know, we know that New Zealand farmers and the industry around them is incredibly innovative, and we see Overseer as a key platform for enabling and encouraging that innovation going forward.
Thank you very much. As I said, there are quite a large number of questions, and we will answer those offline. But thank you for all those who asked a question. I'd now like to move on to a series of 3 short talks by representatives from industry to highlight the work they are doing in being able to provide tools and technologies for farmers to be able to estimate their on-farm emissions. Our first speaker is Dana Carver, and Dana is a program leader for the Dairy NZ Step Change program, a 5-year program that aims to help farmers increase profit while reducing their footprint. Dana has had 25 years experience in behavioral change and is a well-being specialist, along with owning her own coaching business where she works with over 400 clients. She was the owner of the PGP Farm Wellbeing Program and is an equity manager of an award-winning farm. And that farm won the Canterbury Farm Environment Award in 2015 and 2016, and is currently the Canterbury Supreme winner for the Ballance Farm Environmental Award. So Dana can actually saying she walks the talk here. So over to you.
So I'm just going to give you a brief overview here of an extension project that we have happening at Dairy NZ, which is about helping farmers, really motivating farmers to total sustainability. So the project objective is to help them get ahead of the game. So it's not about just responding to regulation. It's about actually helping them future-proof their farms so that whatever regulation comes in, whether it's now or it's in 5 years or it's in 10 years, that they're able to respond to the needs of the environment. So it's really, in order to do that, we need to get farmers to be looking at 3 things together. How do they reduce their greenhouse gas emissions? How do they improve water quality? But at the same time, maintaining or even better, increasing their profit. And there's a sweet spot there, a system that we want to help farmers find. And that is definitely linked to knowing your numbers. So what is Step Change? It is a project that's focused at change at pace and scale. And we do have an aim that in 4 years, by 2025, that we've had 5,000 farms switch to this future-proof system, or they are future-proof. And I will talk on my last slide about what that means. Basically, we have a new integrated approach that our extension officers are using on the ground to help farmers understand how future-proof they are, and that involves knowing their numbers, which I will get to soon. So to begin, we spent a lot of time, this is a lot of social science and behavior change science behind this project. We've got 3 main audiences. So we've got those that are ready to act. Just tell us what to do and we will make the changes necessary for the environment. We have those that are ready to learn and they're asking questions. They're maybe not ready to act yet. And then we have those that are not yet ready at all. So we have messages for all 3 of these groups. For those that are not yet ready, we're working on what we call a Rise and Shine campaign, where the world is fundamentally changing around us. Farm system changes are going to be needed. We can do this. We have information and process to help you. And let's take pride in who we are as farmers and continue to lead. You know, we are the world's most sustainable farmers. It's just about staying there. So those are our message for those who aren't yet ready to act. For those that are ready to question and learn, we just want them to know that there's a lot of options and levers, that the best levers really depend on your farm, your business, and your situation. We have environmental and farm management tools to provide guidance, so we have ways to actually support farmers through. But what those tools do in the end is they help farmers to know what their numbers are and then to know those mitigation options. That is the key. So for those ready to act, once they know your numbers, which I'll get to in a minute, It's about creating a plan for pulling those levers and changing your system, and then getting support to implement those changes, and then sharing what you've done with others. So this is just really a high-level review of what we're trying to do really for all farmers. And of course, we'll be working with partners to achieve this. But just to get a little bit into the numbers, so we have worked hard to come up with some agreed metrics for farmers to measure how they're going on farm in all three of these areas. So we have come up with 3 different KPIs around greenhouse gas emissions. We've come up with 3 around profit, and we've come up with 3 around water quality. Happy to share these slides if anybody wants to see them. The KPIs for greenhouse gas, of course, will be refined as Hawaka Ekanoa process develops, but we have to start with somewhere. We can't wait until we have clarity. There's no reason that we can't start measuring these things and getting farmers thinking about it now. But I wouldn't say that these agreed metrics are actually the know your numbers. The numbers that we think are really important, that we want to be working with farmers on, are integrated numbers. That's getting them to look at these together. So we've spent quite a bit of time with our scientists and our economists working on some quadrants. And we want to use these as a tool. So what we've got here are 4 different quadrants, and possibly we probably only need 1 of the bottom quadrants, but we do have 2 that are linked to greenhouse gas, so I've just put them on here. But basically the first one is your profit and your debt. So what this is basically is your debt to asset ratios. Okay, so just on all of these, the y-axis is operating profit per hectare. So what we're trying to do is get farmers to think about how this is in relation to their profit. Because if making these changes is going to make them not profitable, then they're not sustainable, and we don't have total sustainability. So basically what we're wanting is all farmers to get into quadrants A and B of each of those. Okay, so a farmer might fall in A and B for their profit to debt ratio because they have, really good production and low cost, or perhaps they just have low debt. And then you've got your profit in nitrogen. And with nitrogen, we're talking about purchased in surplus, not the nitrogen leaching, but purchased in surplus. And once again, that is compared to your profit. Are you following in A and B, up in the A and B quadrants? The ones that will interest this group the most, I'm guessing, are profit in methane. So this is methane emissions. So it's kg of CO2 equivalent per hectare per year. And so it's about getting farmers to know where do you fall? What is your number for that? And how does it relate to your operating profit per hectare? And then the one that we probably would use more around your greenhouse gas emissions is your profit and your dry matter intake, which is basically your total feed eaten. So these are the numbers that we want farmers to know. And this is our dream, that each farmer actually knows where they fall in these quadrants. And then the ones where they fall C and D, those are the levers that they have to start to pull. So just the last slide that I have here is, so that sweet spot, that future-proof system that we want to see 5,000 farms on in the next 5 years, what is it? It's basically that they have a current time-bound FEP, but then that they fall in quadrants A and B for the 3 main quadrants. And if we can get them knowing those numbers, mapping them, and starting to make that change, then it doesn't matter what regulations come on board or show up nationally or regionally, they're going to be able to make that change.
Thank you, Dana. And for our next talk, I will pass over to Andrew Kempson, who will talk around some of the things that Fonterra are doing to help with on-farm estimation of greenhouse gas emissions. Andrew has over 10 years experience with the dairy industry, designing, implementing and leading on-farm behaviour change programs at scale. He's worked on the Fonterra Farm Environmental Planning Service, the Fonterra Nitrogen Management Programme, and the upcoming delivery of greenhouse gas reports for all Fonterra dairy farmers. Originally hailing from Masterton and educated at Massey, Andrew has now found a new home in Morrinsville's vibrant rural community. And he has an acute awareness of the responsibility that Fonterra has to ensure that rural communities are supported in the transition to a low carbon economy. More recently, Andrew has been seconded to Hawaka Ekanoa, the Primary Sector Climate Action Partnership, and he is the current program manager there. Over to you, Andrew.
Good morning. I'm Andrew Kempson, Environmental Program Lead for Fonterra. Sustainability is a critical part of Fonterra's strategy. This presentation covers some of the key sustainability priorities for us, as well as some of our on-farm support services for our farmers. Food is at the centre of some of the world's most significant global sustainability challenges. How we feed 10 billion people by 2050, the micronutrient deficiencies, and our health challenges. The world's population is set to increase to 9.7 billion in 2050. This is expected to drive a 50% increase in demand for food. Many people don't have access to adequate nutrition, and 815 million people are malnourished around the world. And we have 2 billion people suffering from micronutrient deficiencies, including overweight, obese, and elderly. And the world is under significant environmental pressure and constraints, and this will inform the context for food producers around the world and ensuring they can continue to operate as well as meet the needs of their markets. Climate change is probably the key environmental driver of this century. The planet has already warmed almost 1 degree and must remain within 1.5. There is a need to reduce emissions significantly to meet the emissions reduction trajectories to achieve 1.5 degrees. This is particularly important for the agricultural sector, not only because ag produces emissions, which are under scrutiny, but because agriculture relies upon a stable climate to produce our produce. Water constraints are also of increasing concern around the world, and in certain parts of the world are very significant, particularly in food-grown regions such as Western USA, North Africa, and Southern Europe. These challenges are high on consumers' minds, particularly because they experience them. These topics are very important context for our cooperative going forward. Sustainability is a concern for consumers. It's starting to impact behaviours around food and beverages. Essentially, consumers are concerned, and the majority are looking for actions from food and beverage companies. This is also informing their purchasing decisions as well. The opportunity and threat is very real. It is our responsibility to tell customers and consumers about what sustainable dairy means, and that dairy has a role to play in a sustainable diet. This can help mitigate the risk, but it helps us leverage our attributes to differentiate ourselves from the competition. Our messaging will focus on our low carbon footprint on farm in New Zealand compared with the global average for milk production. New Zealand has a on-farm global footprint that is approximately 1/3 the global average. New Zealand dairying has a low on-farm footprint compared with the rest of the world based on the publicly available information. The on-farm carbon footprint for Fonterra milk production in New Zealand is 0.91 kgs of CO2 equivalents per kg of fat and protein corrected milk. Fonterra New Zealand's on-farm carbon footprint is approximately 1/3 the global average carbon footprint reported at 2.5 kgs of CO2 equivalents per fat and protein corrected milk. Fonterra New Zealand's on-farm emissions are lower than comparative regions such as Ireland at 1.14, Eastern Europe at 1.34, Western Europe at 1.37, and North America at 1.29. Dairy produced in drier climates or less efficient regions produce 3 to 5 times the emissions such as Asia and Africa. This is supported by external reports which are in close agreement with this data calculating that New Zealand dairy has a low carbon footprint compared to the global average. The on-farm footprint makes up 90% of Fonterra's emissions. This is particularly important as we know food miles and local sourcing is becoming an increasing trend with major hotel chains and companies committing to local sourcing. Manufacturing and distribution comprises of a small component of Fonterra's total carbon footprint. Manufacturing makes up 9% and international distribution makes up the remaining 1%. Even including emissions from the manufacturing and international distribution, the footprint of Fonterra's ingredients can often be lower than the locally sourced product, given that Fonterra's on-farm footprint is less than 1/3 the global average. So there are clear risks and opportunities for New Zealand farmers. Even though we hold a world-leading position, it does not mean we should not drive to improve further. If we reflect upon last year's NZAGRC conference, this slide was shown to the audience, showing that 2% of farmers know the greenhouse gas emissions from their farms. This low understanding of where the sources of emissions come from on farm becomes the first step for fostering farm change, as knowing your greenhouse gas and where your greenhouse gas emissions come from is the first step towards being able to reduce your emissions. To support this, Fonterra is using its existing farm sustainability programs to provide all of its cooperative farmers with a greenhouse gas report in October this year. These reports will fit seamlessly alongside our existing nitrogen management reports, and this program will be used to underpin the market claims that relate to the care for cows, grass-fed and non-GMO certification and market claims. These reports will be used to support and inform the delivery of farm environment plans for all Fonterra cooperative farmers by 2025. FEPs are a core focus in our engagement with our farmers on sustainability and help support the adoption of good management practices that positively impact sustainability. Thank you.
Thank you, Andrew. Our next talk, I'll move on to dairy, beef and lamb New Zealand. And Jeremy Baker will give that talk. Jeremy is the Chief Insight Officer at Beef and Lamb NZ. He's had a wide experience in strategy, analytics and senior leadership roles in the industry, in education and in government. And he's previously Deputy Vice Chancellor at Lincoln University. He's focused on providing beef and lamb and sheep and beef farmers with the insights and tools they need to tackle the issues that matter to the sector. Jeremy is the Beef and Lamb New Zealand member on He Waka Eke Noa, the 5-year joint government industry partnership to develop farm-level emissions reporting and management. So over to you, Jeremy.
Good morning, Jeremy Baker here. I'm here to give you an update for the sheep and beef sector on our progress on climate change emissions. I'm the Chief Insight Officer at Beef and Lamb New Zealand. So overall, the headline is that sheep and beef greenhouse gas emissions have significantly dropped in absolute CO2 equivalent terms since 1990. And that's been driven by a number of things. The number of sheep has more than halved. But the amount of lamb production, for instance, has only dropped by 9%. So there's been a significant improvement in the productivity of the sector, able to produce more value and slightly less product, but considerably less GHG emissions. The story is similar in the beef sector, including dairy beef. Overall head of cattle has dropped by 19%. Dairy production has made up for some of that. Overall, there's been a 6% reduction in GHG emissions since 1990, not quite so much. And production's only down 2%, mainly from rearing dairy calves. The production efficiency of the sheep meat sector has improved by about 1% per year since 1990. And there are a few probably restrictions to continuing that. So the continued focus is on the management of methane emissions. For our sector, nitrous oxide is very much a secondary issue. Moving on to the other half of the equation, the sheep and beef sector has very significant sequestration. We have over 2.8 million hectares of native vegetation on sheep and beef farms, and about half of that is native forest. It's the second largest holding of native forest and biodiversity after the Crown Estate. We're also estimated to have about 180,000 hectares of pine forestry blocks. And our vision is for a mosaic of landscapes where vegetation is fully integrated into farm systems and offsetting the biological emissions that are happening on that farm. Now, unfortunately, that kind of sequestration isn't really easily captured by the ETS as it works at the moment. And that's why the He Waka Eke Noa primary sector climate change action program is really important as a mechanism for capturing that and recognising it. So move on to our ongoing commitment to action. Of course, we're proud of what we've achieved so far, but we are committed to being climate neutral by 2050 and to having no further climate impact. And that's particularly through offsetting, but also through the particular behaviour of methane in the atmosphere. We're very active participants in He Waka Eke Noa. And we're really focused on helping farmers to know their emissions, know their offsets, and know their options for addressing what's left. We'll be working with the He Waka Eke Noa partners to ensure that all farmers have a farm plan, understand their emissions. And all of this, of course, is not just from a regulatory point of view, it's also from a consumer point of view. So a lot of this underpins our origin brand, Taste for Your Nature. So it's a fully integrated strategy and we're committed to achieving it. Thank you very much.
Thank you to all our three presenters, and we can now move to some questions. And the first question I have really is for you, Andrew, and it comes to a question around the interactions between Overseer and your own programs, and are you actually working together to ensure alignment between the two approaches?
Yeah, thank you, Harry. Great question from the audience. Yes, we see no value whatsoever in repeating any of this. So for a situation where a farmer is already using existing OverseerFM software, has an existing OverseerFM account, and gives the permission to Fonterra, then there's no expectation, no requirement for us to do anything additional. Check the data that's been used to drive that, but fundamentally there's already a robust report that's already available there that we will then basically pick up and report back to the farmer, along with some of the benchmarking opportunities that that'll come from how we integrate our entire data set. So where a farmer's already using OverseerFM, then absolutely we're using that output.
Thank you. Could I move on to a question for Dana? And this was around the targets, and again comes back to the issues around carbon dioxide equivalents and knowing that New Zealand actually has targets now both for 2030 and its nationally determined contribution, both in terms of carbon dioxide equivalents and a separate methane target. When you're setting KPIs, are you using KPIs for individual gases as well as KPIs for in carbon dioxide equivalents?
So while we are asking lots of questions on CO2 equivalent, I just want to make it clear that this is about actually motivating farmers to work, and what we're going to be using is the dry matter intake. So that is what, from looking at the farmers that are willing to make changes, so we've done a lot of talking to the farmers and understanding, it's really not about talking the CO equivalent to them. That's not hitting the mark with them. It's literally looking at their dry matter intake. So they need to understand how dry matter intake is related to their methane emissions. But that's what they will be measuring, and that's where we seem to get the buy-in. That's why I don't think I made that clear in my presentation. So that is the focus if we want farmers to change.
Thank you. This is a question I think for all of you. Is about if we keep seeing data that show that New Zealand's emissions per unit product are lower than the rest of the world, shouldn't we in actual fact be increasing our production rather than attempting to put any constraints on production?
So I'll have a go at that, Harry. I think the focus at beef and lamb and for sheep and beef farmers over the last few decades has actually been on trying to be more efficient and to produce more value rather than just more product. And that's what we've been achieving, and we're going to continue to do that. But yes, we do have to care about emissions leakage and about not swapping out efficient production in New Zealand for inefficient production elsewhere, and that is part of the Paris Climate Accord, and that is part of the sort of the discussions that we have to have through He Waka Eke Noa.
Thanks, Harry. No, it's a great question. This is kind of one of the balancing points that we've sort of got to work our way through in terms of how we sort of transition to a low carbon economy. So we do need to be mindful around the settings not to encourage carbon leakage, but then we also need to acknowledge that actually from a food megatrend perspective, we also need to still display action on both reducing our absolutes and also reducing our intensity. So we have, I think Fonterra's top 5 customers in terms of value and volume have very aspirational climate targets that are far more aspirational, for example, than what the government have used in Zero Carbon Act. So it does mean that for us to hold a world-leading position and to meet the needs of our customers, we need to continue to drive for both emissions reduction from intensity and absolute perspective.
And I would second that. So when we're the farmers that are ready to act in our program, they're saying the same thing. They're saying we have to continue to lead. This is what our consumers want, so we understand. So let's come up with a solution. But the farmers that are questioning, that's exactly, they're not quite ready to act, and that's what they're saying. Shouldn't we just be increasing our production? Which is exactly why we have to get those that are ready to act to start sharing their story with the other ones.
A question really for Andrew here. You've outlined the issues around accounting very well, but what is Fonterra doing to help farmers actually reduce their emissions as well as know their number?
Yeah, great question again. And I think that talks to kind of the last slide on my presentation. It was around the Farm Environment Plan, and it's, the Farm Environment Plan is that key vehicle that we use to incentivise and drive for change on farm. So that's us providing all farmers that supply Fonterra with a Farm Environment Plan and put together by a certified professional who is up their driveway, looking at their farm, looking at their farming system, looking at their motivations, looking at at how and where they farm, and providing them with guidance in terms of farm planning advice around things they can do better. And part of that discussion will be informed by the greenhouse gas emissions report. So part of the discussion around the kitchen table will be, let's look at this and what actions can we put into your farm plan to improve it.
And I could carry on. There's a lot of questions I could carry on for quite a long time, but I will just do one final one, and we will answer the other questions offline. It's one for you, Jeremy. It's you highlighted the issue of carbon sequestration, but the questions come in. Is it only a temporary solution, sequestration in trees, and would you eventually have to end up planting the whole of your farm in trees? And so how much can you rely on trees as an offset for GHGs in the longer term?
It depends what gas you're offsetting. If you're offsetting the warming of methane, which is not a permanent it's a short-lived gas, then it is a long-term strategy. If you're trying to offset CO2, which is a permanent addition to warming, then no. And that's why the Parliamentary Commissioner for the Environment made a very strong recommendation that you should only use biological offsets for biological emissions, and fossil fuel emissions should be dealt with by actually reducing them.
Thank you. So I said there are lots of questions, and we'll attempt to answer those in due course. So I'd now like to move on to the talk around soil carbon. Soil carbon is something that raises passions everywhere. Currently not accounted for in our emissions profile, and I think we'll understand a little bit more why and what the issues are and some of the problems associated with soil carbon after our talk. So this talk is from Paul Mudge. Paul is a scientist at Manaki Whenua Landcare Research. He has a farming background, coming from a hill country beef and sheep farm and a commercial goldfish farm near Waitomo Caves. He completed a diploma in agriculture at Massey University before working as a stock manager on an intensive beef, sheep and deer farm for 4 years. Subsequently, Paul completed a PhD in soil science and ecology, and then a master's and a PhD with a focus on carbon and nitrogen cycling in pastoral systems at the University of Waikato. Said for 7 years, he's now worked in research where he conducts and coordinates research on interactions between carbon, nutrient and water cycling in agro ecosystems. Over to you, Paul.
Kia ora. It's really great to be here and being able to present on soil carbon. I'm Paul Mudge. I'm from Manaki Whenua Landcare Research, and I'm based in Hamilton. I used to be a farmer, and now I'm doing science all related to agriculture. So I really want to acknowledge my co-authors here, so particularly Louis Schipper, who's helped a lot with work in this area over a number of years, helped putting this presentation together, and Stephen McNeil, who's done a lot of the statistical analysis behind the work that we've done. And also there's many other people that you'll see on references throughout this presentation. So just a quick outline of what I'm going to talk about today. First, sort of start off with, well, how much carbon do we have in New Zealand soils, and what's the importance of soil carbon? I'll then briefly just go into the mechanics of how we actually make measurements of soil carbon. Then we'll look at briefly a current approach for determining soil carbon stock changes at the national scale. Then look at a new project around national soil carbon benchmarking and monitoring. Outline a methodology, some work that's been done around farm scale soil carbon benchmarking and monitoring, and then really quickly look at an approach that's been used to test the effects of different management regimes. So firstly, how much carbon in New Zealand soils? For the whole of New Zealand, the average is 90 tonnes per hectare. And you can see in the figure there that it's quite highly variable. So there's very little in on the Southern Alps, where it's all rocks, and there's lots around Taranaki on the nice, rich volcanic soils. So you see that across New Zealand, there's a lot more than in Australia. Australia's only got 30 tonnes per hectare on average, and the USA has got 45 tonnes per hectare on average across the whole country. So we've got a lot of carbon in our soils. So why is soil carbon important? The first thing is it's really important for soil health for a whole number of reasons, such as the structural stability of the soil. It's really important for nutrient cycling. And then because there's more carbon stored in soils than in the vegetation and atmosphere combined, even a small change in soil carbon can actually have a release of CO2 into the atmosphere, or it can take CO2 out of the atmosphere. So just quickly, the basic mechanics of measuring soil carbon. You need to collect a sample of a known volume of soil, and then you really want to take that sample, send it to a certified laboratory, and they'll determine bulk density and the carbon concentration. And then from that, you calculate the carbon stocks from the concentration and the soil mass. And I'll just emphasize here, I don't have time to go into detail, but it's really important to note that if you're making comparisons of soil carbon stocks between treatments or between two sampling times, you have to do that on an equivalent soil mass basis, so that if you've got a change in the bulk density, that is accounted for in those calculations. And there's a couple of really good references there that explain how to do that. And I just thought it'd also be useful to point out that measuring percent carbon in the topsoil isn't sufficient. It can actually lead to a misinterpretation of results. It's really important that you get the bulk density as well. And it'd be really good if, I think, in I guess the agricultural community, if we could move the discussion from percent carbon to carbon stocks, and that, because that's what's important from especially the greenhouse gas perspective. So just really quickly, I'll go through three sampling methods that are commonly used, or the methods used for determining soil carbon. So the first one is using pits and short cores or bulk density rings. That's been used for, it's a standard, it's been used for many years, and you get a ring and either press it or gently drive it in or carve it into the soil, and then when you've pressed that in, you cut it off at the bottom, and you've got a known volume of soil for that depth, and then you dig the pit a bit deeper and you repeat that until you've got to the required depth. Now, the minimum for all methods should be 30 centimetres for soil carbon accounting, but the deeper the better. A method that we've increasingly been using in New Zealand recently is using deep continuous cores. So this is where you drive in a core, and you can drive it into 30, 60 or a metre, and then you get out intact cores, and when it goes well, this is a really efficient way of collecting soil samples, much quicker than digging pits and carving in small cores. And the final one is using the quantitative pit method for stony soils. And it's not too hard, but it's very tedious, and it's probably why our stony soils are underrepresented in our sampling. And so you've got a sampler, you have a frame, and then you dig out the soil from that, you sieve out all the stones, you weigh the stones, you weigh the soils, and then you backfill the hole with beads with a known volume to weight ratio, and then you weigh those, and it's very accurate, but it's very tedious. But it's really the only way to get a good number from stony soils. So now, just stepping back to how do we determine changes in soil carbon stocks in New Zealand and currently. And if we look, we've got a system that we can use to quantify changes in soil carbon stocks in response to land use change. And it's a statistical model, and it's developed following IPCC methodology. And it predicts change in soil carbon stocks with changes in land use. And so basically in the model, the reference land use is low producing grassland, and that is 106 tonnes of carbon per hectare. And then if you went from a low producing grassland to any other land use, it predicts that there will be a loss of soil carbon. And if it goes the other way, from those other land uses to low producing or high producing pasture, you will get an increase in soil carbon. A few assumptions with that method is that it assumes that equilibrium is reached after 20 years for any given land use, and it doesn't account at all for any management effects within a land use. And also the model, it's based on carbon data collected over decades, often for other purposes, and it's not fully representative of New Zealand's agricultural land in terms of tends to be a lot of sampling sites and their pubs and research stations. So we actually don't have a system for directly measuring changes in soil carbon stocks for New Zealand's agricultural land. But that has or is just changing, because we've just started a new program for national soil carbon benchmarking and monitoring. And that's for agricultural land. So what we've got is we've got 100 sites in each of 5 broad land use classes: cropland, horticulture, dairy, flat to rolling dry stock, and hill country dry stock. These are being sampled to 0.6 of a metre, and all the sites have been randomly selected in a statistical framework, so that we're pretty confident, or we are confident, that this will be a representative sampling of those different land use classes for New Zealand. The plan is to do 3 samplings of these sites by 2031, so sampling every 4 years from 2019. And the key thing is that this method or the system has been designed to be able to detect change of 2 tonnes of carbon per hectare for each of the broad land use classes if a change of that magnitude should occur. So we've also been doing some work on farm scale soil carbon benchmarking and monitoring, and there's quite a lot of interest in this at present. It's a very similar approach to the national scale monitoring, but the one thing that we have is we've got less information on soil carbon stocks at the farm scale. So it's harder to design a sampling or recommend a sampling intensity with the information we had. So actually probably the best approach would be we do a pilot sampling and then do a power analysis, statistical power analysis, to determine the number of samples that are required. We do have one farm in particular where we've got some really good information, and it's Massey University #1 dairy farm. And there was a study by Brendan Malone and Carolyn Headley, and they basically gathered all the information that they knew about this farm around the soils and the slopes and all those things, and then they got some the existing carbon data they had from the national model to basically get the best estimate of the carbon on that farm and the variability, and then they had a very detailed sampling plan and measured soil carbon across that whole farm. So they've got some really accurate information for that farm. we used that data and we picked 10 of the samples randomly that they had analysed for. And what that determined was that with those 10 samples, we would have been able to detect a change in soil carbon of 5 tonnes per hectare. So an increase or a decrease of that magnitude if we'd taken 10 samples from that farm. We would have needed 51 samples to detect a change of 2 tonnes per hectare. This farm was a really uniform farm in terms of soil carbon, so it actually didn't matter. You didn't need to break it into different soil types or management units to get a pretty accurate prediction or be able to be quite certain of the change in soil carbon with a relatively few samples. In some cases, the soils on a farm will vary quite a lot more, and there can be quite big differences in management between different blocks. And then it's quite useful to make sure that you representatively sample within each of those different strata. And so we've come up with a really simple approach in the report that we've done for MPI, and it's based on using land management units that are commonly almost required now in farm environment plans, and then use that as the basis to determine where to put your samples across the farm. They still need to be randomly allocated within the land management units, and then go and collect those samples. And you can see there's lots of different symbols on the here and on the screen. This is just to show that you can analyse all of those samples individually, or you can actually bulk samples from the same strata, the same colour, into one bulk sample. So you've got 3 bulk samples per land management unit. Now, there's all the details on the pros and cons of using the different approaches are explained in this report at the bottom of the page there. Finally, one other thing that we've done quite a lot of work on is testing for specific management effects. So that previous slide, that will tell you if you sample across, say, 3 land management units and with enough intensity, you'll be able to determine if soil carbon is increasing or decreasing on that. You can't explicitly say that that was due to management in terms of the changes, because you have no true replication of those different blocks of the farm. A really good way to test for management effects is using paired sites, and this can be applied to management and different land uses. Forestry, cropping has been done, and an example here is we've done some work on irrigation. So got an irrigated and a dryland area on the same soils, so they're really closely matched. Everything is the same except for the difference in management pretty much. Take your cores and then and send those to the laboratory for analysis. In this particular study, we sampled 124 paired sites, and a key thing here is that you need to sample a lot of sites, and they really need to be independent sites, so probably a minimum of 15 paired sites to be able to detect a meaningful difference, if there is one, between different management regimes. And this is best applied at between farms rather than within farms. So just a quick summary and I guess next steps. So it's really exciting. We've got a national benchmarking and monitoring system up and running for soil carbon, and there'll be spin-offs for other soil properties as well. I think this will be a very valuable resource going forward. So 500 sites, and we should be able to change of 2 tonne per hectare for the 5 broad land uses if a change of that magnitude happens. We'll finish the first year of benchmark sampling by September 2020, and then we'll get some first estimates of change by around 2022 and 2023. And so it'll be really interesting to see what that shows. We've also developed a farm scale method, and key there is recommend using land management units within farm environment plans as a starting point for study design. Can make it more sophisticated, but that's a good starting point. This is undergoing the report that we did on this work is undergoing a few revisions, and it should be released by MPI soon, hopefully. And if we want to look at specific management effects outside of research experimental design, where you have a replicated plot trial, paired site sampling is quite a powerful approach. I've just put on here a slide so that if anyone wants to go back and have a look, there's some detailed information in some of these papers and reports. It's not exhaustive, there'll be other good resources as well. And finally, yeah, thank you. And here's just the contacts for myself and Louis Schipper, and would be very happy to take questions and talk about this topic. It's a lot of interest and it's moving very fast, and so we've got some nice systems up and running, and yeah, looking forward to the future. Thank you.
Thank you, Paul. Now, before we move on to questions, I would also like to introduce Professor Louis Schipper from Waikato University, who has co-authored that video with Paul, and we're very lucky to have Louis here to be able to answer questions. Louis is one of New Zealand's foremost authorities on soil carbon. So I'll try and direct questions to either one or both of them as we go along. The first question is around that number you quoted as an average value of 90 tonnes per hectare. But what is the range, and what does that range tell us about the ability we have across New Zealand soils to increase soil carbon? And I think probably both of you would maybe answer that one.
As you would have seen in the map on the earlier slide, there is a very large range from kind of pretty much zero if there's just a lot of gravels to, in our nice allophanic volcanic soils, it can be up to 300 tonnes of carbon per hectare just in the top 30 centimetres. In our agricultural soils, it's probably more, you wouldn't have any of that as zero because they wouldn't be very productive. So some of the lowest you might expect is probably 20 or 30, particularly in our very stony soils. And in terms of scope to increase, there has been some work done that models that there is theoretical scope for increasing our soil carbon in New Zealand soils. We currently don't have a lot of proven management practices that definitely will increase soil carbon. We do know that if you change land use, so if you go from a cropping soil to a pasture soil, pasture in the long term, you will get a reasonably large increase in soil carbon, and we're pretty confident about that. Specific management practices within a land use, we're not quite so confident about that.
Louis?
Kia ora. Thanks, Harry. Yes, I think one of the things that's really important to remember here is that not all soils can store the same amount of carbon. And that's why they have different amounts of carbon in them. So I guess the key here is that you may be able to elevate carbon in different soils, but you're not going to be able to get them all up to the very high level. So those allophanic soils that might have, say, 300 tonnes of carbon in them, that's an amazing amount of carbon. But if you've got a more sandy soil, the opportunity or the likelihood that you're ever going to get that over, say, 150 tonnes of carbon is very low. At least I don't know how that might be done. So soils have a natural level of carbon that is different for the same land use. It doesn't mean that we can get all soils up to the same very high level.
Thank you. Could I have a supplementary to that one, which integrates another question, and it comes back to Paul's comments about management practices. We've seen a lot of focus in the press recently on regenerative agriculture and regenerative agricultural practices, and particularly strong claims around the ability to increase soil carbon. And I just wondered if you'd make a comment on that one as to whether you feel that adopting those principles is likely to be a way that many farmers could increase their soil carbon. And I'll again give that to both of you.
Well, I'll go first then. I think some of the principles, the very generic principles behind regenerative agriculture of increased plant diversity, there is some good evidence from internationally and a little bit from New Zealand that has potential to increase soil carbon. Most of the international evidence is not from intensive graze pasture systems, it's from detailed plant kind of cut experiments. And the other thing that regenerative ag does is they let the pastures grow longer and in general, and then don't have as high utilisation, and so therefore there's more of that pasture material that isn't ingested and respired as CO2 and is left on the soil surface, and that could potentially become incorporated into soil organic matter. And modelling suggests that that could increase soil carbon, but I guess we don't have any really quantitative measurements on that yet in New Zealand.
Yeah, if I can add in there too, I agree totally with Paul. Some of the principles that are put forward in regenerative agriculture are certainly good farming practice, right? And one of the key ones that is about keeping plant cover on your soil as much as you can. And so if you can keep the grass growing, you're continuing to have carbon inputs into your soil. Anytime the soil is bare, you're going to lose carbon through ongoing soil respiration. So some of the components of regenerative agriculture, or of what I understand is viewed as regenerative agriculture, are certainly very well supported by the literature and studies that have been done. The challenges around some of the other suggested approaches in regenerative agriculture, you know, the evidence may not be there. And one of the difficulties that we sometimes face in sort of trying to understand what people are wanting to do on their land is they're talking about all these different interactions that result in carbon increase in soil or better outcomes. And it becomes very difficult to untangle all of these so that we know what is best to do where. But certainly some of the principles that have been put forward in regenerative agriculture have been supported in the literature for many years now.
Thank you. Can I ask a question in actual fact? That your soil carbon monitoring program is going until 2031. Why does it take so long for us to get answers to this? 2031 is a long time ahead. So why do we need to go out to 2031?
One of the reasons is soil carbon generally changes relatively slowly. In general, we wouldn't expect it to change by more than 1 tonne per hectare per year in a pastoral system. And across a whole range of sites across New Zealand, it would be almost certainly to be smaller than that. And one of the reasons to go out that far was to try and get 3 measurement points. We were going to, and I didn't say this clearly in the report, the idea was to do a benchmark monitoring over rolling sampling over 4 years, and then resample each of those sites over 4 years, and then it gives you 3 points, so you can actually fit a regression line, and that gives you more confidence that if a change is detected, that it will be a true and ongoing change in a certain direction. Whereas if you just measure between 2 points, that's less robust.
Yeah, if I could add to that, one of the underlying things that we need to think about is that one of the farms that we work at, if we walked from one end of one of the paddocks to the other end of the paddock, the carbon stocks in those soils could change from, say, 150 to 100 tonnes per hectare. So there's this enormous spatial variability that Paul showed. And what we're trying to do is measure changes of 1% per year change through time of a very variable kind of system. That means that you need very careful design in the way that you do your sampling, as Paul has shown, and where you take your samples. And then you need the time to be able to pick up those very small changes in amongst the background of quite a lot of spatial variability within a paddock or even within a farm. So picking up these differences is really challenging, but it's really exciting to see that we have a kind of a plan that should allow us to do that.
Okay. And again, we could continue the question and answer session for a lot longer than we have time for, but I will ask one final question, which is around the technologies that you use for taking your samples. Now, it looks quite complicated. You know, you said deeper the better. You showed the different types. are there new technologies on the horizon that could make this simpler, cheaper, more tractable?
Who's going to take that one? Me?
I can do that one, Paul. Look, I think there are other methods that we can use to get at what total carbon stocks are in soil. The real key that we have here is that we're not as interested in the total stock as we are in the change in the carbon stock. So we might be able to make, you know, sort of broad scale assessments of about how much carbon we have in the soil in different parts of New Zealand or on a farm or something. But getting at the actual change, like I said before, we're trying to pick up a change of like 1 or 2% carbon change in a farm. And so I don't think that we're quite there yet to reduce the costs or the complexity. It's not that complex to dig a hole or take a core down. But I think apart from that physical measurement, if we're trying to measure these very small changes, I think we're kind of stuck with this method for a little while for measuring change.
Can I just add to that? It is really important that we emphasize it's measuring change, which is the most important. If we're talking about it from a greenhouse gas perspective, it's not how much you have that matters, it's how much it changes. And yes, I think in general, right now we do have to collect soil samples using those methods that we've described, or very similar methods. There are lab analytical techniques, spectroscopy, that is developing quite rapidly, and particularly mid-infrared spectroscopy is proving quite accurate. The gold standard is still the combustion technique, and mid-infrared could and can reduce the cost slightly, but there is still a bit more processing. But over in the next, 5 to 10 years, there may be some improvements there, but it's not going to be absolutely groundbreaking in terms of being able to accurately quantify stock changes from space. Remote sensing would be my take.
Thank you very much. And I'm sorry we have to bring that to an end. There are lots more questions we could ask, but we will ensure that those questions are answered once we finish this. So just for me, it's a thank you for coming to this 4th webinar in our Towards a Low Emissions Futures series. I'd like to thank all the presenters for their time spent preparing the videos and their time to answer the questions. Just for participants who've enjoyed this and wish to join into the next webinar in our series, you will have to register separately. It is next Tuesday morning. It will be a different link, so you do need to register separately. You can't use the same link that we've been using. Once you leave the session, we will have a short survey, and we would love your feedback. If there's any suggestions on how we can improve the presentation, how we can improve the experience that you have from attending these events. So again, thank you very much for attending. Thanks to all the presenters, and hopefully we'll see you all next week. Thank you.